So basically today we're going to be talking a little bit about circles. So last time we talked a bit more about puzzles, but today we're going to be going back to some geometry explainers. So whenever we think about a circle, which is literally just this, we usually think of something that kind of looks like this, right? A round shape that basically looks like that. But does anyone know the exact definition of a circle, or how you can create a circle using just sort of conceptual ideas, like what a circle actually is? Does anyone have any ideas, or does anyone know that? Well, a circle is, in essence, a circle is where you have a center point like this, right? So if you have a center point, then you can draw all of the points that are a certain distance away. So let's say that we want our distance from the center point to be 3. So one point right here is going to be 3. So this length is going to be 3. However, however, we can also say that this length is 3. But these are all going to be 3. But basically, there's an infinite number of points that are 3 sort of units away from any center point. So, in essence, a circle is the shape that makes up every single point of that is 3 away from a certain center point or a certain distance. And we call that distance the radius. So, for example, if we draw a circle like this and we center it here with a radius of 3, then this circle has a radius of 3, since every point on this circle is a distance of 3 away from the center point, which is right here. So that's basically the definition of a circle. Now, another way to think about it, which is probably more useful, is to say that, well, every point on this circle, like if you have this point, or this point, or this point, all of these points are 3 away from the center. Since all of these points are 3 away from the center, or 3 units, it could be centimeters, it could be inches, but all these points are the same distance away from the center point. So basically, any point on the circle is going to be 3 away from a center point. And that center point is going to be right here. This is the definition of a circle. But, well, there's also a bunch of other parts of the circle. So we talked about the center point, which is going to be right here. This is the center. I think that's the center. Well, since this is called the center, well, what are we calling? And we remember, we can call the distance to any given point on the circle the radius. So this point is called the radius. This distance is called the radius. So in this case, the radius, which is easily represented with r, equals 3, right? Since this length is 3. And since any other point on the circle is distance 3 away from the center. And if you actually want to figure out what exactly the distance, we can use the Pythagorean theorem, but we're not going to be discussing that today. We're going to mainly discuss the geometric implications of a circle. So the radius is this distance right here. Now, the diameter, or double the radius, which is basically the distance from one end to the opposite end, passing through the center like this. This distance, let's just erase this, is called the diameter. Diameter. That distance is called the diameter. Now, the diameter is going to be equal to 2 times the radius, which in this case, since the radius is 3, that means that the diameter is going to be 6, right? So does this radius, diameter, center stuff make sense? You might have learned about this in school before, but yeah. Okay, so now that we have this idea set, we can also look at the circumference. And the circumference is the distance all around this entire circle. So you can think about it, if you sort of unwind the circle, like you take the circle and then you like unwind it like this. You sort of unwind the circle. It used to be a circle like this, and then you unwinded it. That would be the distance of all the way around the entire circle. That's called the circumference. So it would be as if, a person was walking along the entire thing, and then how much distance would they have to walk to get back to this point that they started in? That is the circumference. And the circumference in this case is actually not that easy to find, right? Because we don't actually know what this distance is right here, for example. It's very hard to figure out what the circumference actually is. But the fact is that all circles are actually similar. So what that means is that the ratio between its diameter, these two lengths, radius and diameter, and the circumference is always going to be the same. So the radius and the diameter are going to have the same ratio with the circumference in any circle, because all circles are similar. And what is that ratio? Well, that ratio is usually what we call pi. So let's actually write circumference first. So that ratio is usually called pi. So d over c, actually it's c over d, sorry. So the circumference over the diameter is equal to pi. And pi is around 3.1415, or 3.1415. It doesn't really matter what the actual number is. In fact, the actual number has an infinite number of digits, which is why instead of writing 3.14159, blah, 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 we just call it pi. But remember that pi is not a variable in and of itself. Pi is actually a number, a literal, real number, no different than any other number. It is a number just like 1, 2, 3, 4, 5, though it has an infinite number of decimals. So it is a real number. It is just a number. But what that means is that if we want to figure out the circumference, or the amount of distance that you need to walk to get around the entire length, how much distance you would need to walk, if we already know what the diameter is, or if we already know what the radius is, then we can figure out the circumference. So, for example, if we know that the diameter is 6 right here, since we know it's 6, then, well, c, the circumference, over 6 will equal pi. And what that means is that the circumference will equal 6 pi, right? Because if we solve an equation like this, then we know that c over 6 equals pi. And if we multiply both sides by 6, then multiply both sides by 6, then this will cancel out, and then we would just be left with 6 pi. So does this idea of pi make sense to everybody? Okay, so next, let's talk a little bit about arc length. So in a circle, well, we know the circumference, right? We know the circumference is going to be pi, is actually going to be pi times the diameter, which we can derive from this formula, since the definition of pi itself is the circumference over the diameter of any circle. And we remember that every circle is similar, meaning that the ratio between the diameter and the circumference is the same. So since the circumference equals pi times d, pi times the diameter, then we can also figure out what the lengths are of sort of smaller sections of the circumference. So let's just draw a simple circle like this. So if we draw a circle like this, splitting it down the middle, like that, and then if we just have a semicircle, let's erase all of them. And then if we erase all of this other part of the circle, just leaving us with a semicircle, like this, then what is this length right here? So if someone was sort of walking along this top like that, how long would they have to walk? Now, we know what the radius is, right? So the radius in this case is going to be 3. So we know that this length right here is 3. We also know that this length right here is 3. This is a semicircle, meaning that it's a circle sliced in half. So does anyone have any ideas as to how we can actually figure out the length of, the length of the area in red, like this? Does anyone have any ideas of how we can figure that out? Or, sorry, the line in red? Using the ideas that we just mentioned over here with the circumference, center, and radius of a circle. Well, a very easy way to think about this is just to think about having a circle like this. So having the entire circle. So let's just draw out the entire circle in dotted lines. Like that. 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 So we have a sort of a semicircle that's drawn out in dotted lines like this. So what is the circumference of this big circle? So remember that circumference equals diameter times pi, which we derive from the definition of pi, which is pi equals circumference over diameter, which is always going to be around 3.14. We can actually calculate what the circumference is based on the diameter using pi to a certain number of digits. So we can calculate that using, well, a calculator. So does anyone have any ideas as to how we can figure out the length of the red, which is this length right here? Oh, oops. Which is this length right here. Or starting off, we can calculate the length of the entire circle like this. Just this entire big circle right here. Okay, so basically what we're going to do is we're going to first find the entire circle's length. And if we remember using the definition, or the entire circle's circumference. So if we remember, we can use the definition like this. So currently the radius right now is actually going to be 3, since these lengths right here are 3. What that means is that we can figure out the diameter, since the diameter is equal to 2 times the radius, right? Because think about it, if the diameter is the radius is the distance from the center point to the edge, the diameter, since it's the farthest possible points, like the opposite points, diameter is actually going to pass through the center. And if it passes through the center and we have 2 points on either side of the center, then the distance between the center and to either of those points is r. And since we have 2 of those lengths, it is going to be 2 of these lengths like this. Oh gosh, it is going to be 2r. So that is why the diameter is equal to 2 times the radius. So in other words, the diameter is just from one side of the circle to the other. The radius is from the center to the circle or any point on the circle. But I digress. Basically, we can take this definition right here, meaning that r is going to be 3, which means that the diameter is going to be 2 times 3, which, as we all know, is 6. Now that we have that, we can figure out what the circumference is of the entire big circle. So what the circumference is of this giant circle right here. Well, if we take that number, we know that c is equal to d times pi, which is equal to 6 times pi, which is pi times 6. Yeah, so the circumference is pi times 6, or 6 pi, which is actually the same circle that we found here. Where the radius is 3, the diameter is 2r, where the diameter is 6, we could do the same thing. And in case you're curious, this number, 6 pi, is going to be around 18.8, around 16.84, which, I mean, 18.84, which is a number that it's not a clean number, but it is still a real number that we could calculate. But right now, that doesn't really matter, so we're just going to stick with 6 pi, since it's easier to work with just pi instead of having to write 3.1 for blah, blah, blah. But how can we take this circumference that we get of the entire circle and move them, like sort of use that to figure out the circle, this length of this circle, like here? Well, what we do is actually, we just split the circle into 2 pieces. So each of these pieces is going to have the same length. So this piece right here is going to have the same length as this piece right here. And what that means is that since they both add up to form the entire circle circumference, we can simply divide this by 2, which means that we will get 6 pi divided by 2 equals, well, 3 pi. 6 divided by 2 equals 3. So another way of thinking about this is just splitting the circle in half. We also split the circumference in half. So if we take half the circle, we're going to get half the circumference. We're going to get half the length of half the arc length. And remember that this is actually an arc. So this is an arc. We're going to half the arc length. Well, now that we have that, we can actually figure out some other arc lengths that are a bit more complicated. But before we do that, does anyone have any questions, concerns, comments about, what's going on here, how this works? I'm not sure if you guys have learned this in school before, but it is a very important knowledge to have, especially if you want to do math competitions or just geometry in general. No? Okay, well, so let's move on to talk about something slightly more complicated, a slightly more complicated version of this question. So if we move down right here, we are going to get a circle that looks like this. So, and let's say that we want to take only 1/3 of the circle. Actually, let's say that we take 1/4 of the circle. So we divide the circle like this. And we form a 90-degree angle at the center, right here. 90-degree angle. Then what the question is what is the length of this line right here? Let's make this a bit thicker. What is the length of the line in blue, or the arc in blue? So we know that the radius is 3, that these lengths are 3. But what is the length of this line, of this length in blue? What is this length? So I'll give you guys a moment to think about it before we talk about, how to solve this, but let me just put this in question mark. And it would actually be nice to add some numbers here. So OA B. And the way we actually talk about arcs in terms of this is to say, well, AB. You can't just write AB, because usually if you write AB, that would just mean that it's a line, and you would be asking what the length of this line is between A and B. But if we want to talk about arcs, we can simply just add a little arc thing on top. And that basically means that we're talking about arcs, and we're talking about what the length of this arc is. So what is the length of the blue arc? Equals question mark. So I'll give you guys a moment to think about it. And if you want to review anything, I can put all of this in the chat. So I put sort of the information that we've covered so far in the chat. So yeah. But if no one has any ideas, we can also just talk about this right now. So basically, the way this works is that we will basically do the same thing as before. So before, we split the circle in half, like this. We split the circle in half, but now we split the circle into quarters. So if we actually extend the line like this, then we could see that the circle is split into 4 different quarters. And each of these quarters are going to be the exact same. They're actually going to be congruent, if you remember that from a couple lessons ago. So congruency doesn't apply to just triangles. It applies to literally anything, any shape. They can all be congruent. And congruent obviously just means that they're the same shape and sides. And in this case, this means that all these side lengths are going to be the same. So this is also going to be 3. This length right here is going to be 3. And these lengths right here, let's just label them. AB, arc AB, will equal arc AC, which will equal arc CD, which will equal arc DB. So that means that all of these arcs are going to be the same length. And what that means is that since all of these arcs, this arc right here, this arc right here, this arc right here, they're all going to be the same length as this arc. And since they all add up to the circumference of the entire circle, which, by the way, if you were curious, we could write a circle like this. We literally just put a dot inside a circle like that, and then we write O. Whoops, there's another dot in that circle for some reason. Yeah, it kind of looks like eyes, but that's basically how we write a circle. We can put it a bit smaller so that it looks like that. That is one way to sort of write a circle. So that means that the circumference of this entire circle we can easily figure out, but we're going to have to divide it into 4 pieces. And to divide that into 4 pieces, well, we just divide this total circumference by 4 to get the length of any of these pieces, or which is going to be our answer, which is AB, which is the length of AB. Well, let's first start by finding the circumference. If we remember, this is the same circle as the one that we've been using before. So the radius is going to be 3, meaning that the diameter is going to be 2 times 3, which equals 6, which means that the circumference will equal 6 pi, right? Because remember that the diameter equals, the circumference equals 6 times the diameter. pi times the diameter, or the diameter times pi, which in this case, the diameter is 6, which means that the circumference is going to be 6 times pi. Now, in this case, we can again use the same method by dividing it into 4. So the length of AB, arc AB, is going to be 6 pi over 4, which we can simplify to 3 over 2 pi, which is just 1.5 pi, or 1.5 pi. Now, notice something here, actually. So notice that the angle formed between AO and B, or AOB, is actually 90 degrees. So an easy way to think about why this is 90 degrees is to think about a circle sort of not just as or arcs, not just as like a piece of a circle, but actually as an angle. So an angle on the center point. So AOB is 90 degrees. And if we move the circle around if we sort of have a 360-degree angle, like an angle that goes all the way around like that, then we would actually have the entire circle. So basically, what I'm saying here is that you can use the angle formed by the two sort of radii like this to figure out the length of the arc length. And the way we do that is to say that, well, the entire circle, the big circle, is going to be 360 degrees. So the entire big circle is going to be 360 degrees. And then, so what that means is that the ratio between AOB, which is this length right here, over here like that, and 360 degrees is going to be the same as the ratio between AB, arc length AB, and the circumference, which we'll just write as C. So why is this true? Well, basically, if we take the idea that, basically, since the radius is going to be the same throughout the entire circle, that means that the length of the arc is also going to be the same throughout the entire circle. This is sort of an interesting idea to think about, but it stems from the fact that a circle is the same length throughout the entire thing. So the angle formed is going to create an arc length that is proportional to the angle on the middle. So if you want to think about this, you can also think about it in the way that every time we increase this angle here by some amount, so let's say that we add an angle here like that, then if we add an angle here, add an additional angle to that angle, add some more, make the angle slightly bigger, then we're also going to make the circumference bigger by the same amount, or the arc length bigger by the same amount on that angle. And you can kind of see that visually here, right? But it is kind of an advanced idea to think about in terms of sort of conceptually, and it is like a little bit of sort of just common sense, like looking at it. But essentially, what this means is that you know that the ratio between the angle on an arc and 360 degrees is going to be equal to the arc length and the circumference. So all properties of a circle sector, or circle arc, are going to be the same ratio as each other. So this might seem a little confusing, but later on you'll sort of see it a bit clearer. So now let's instead take a quick circle, and then I'll just tell you the angle, just the angle, and we'll put this here like that. Tell you just the angle. We'll just leave this formula right here. Just the angle right here like this. Just draw a random angle right here. And let's say this angle is 60 degrees. Then what is the length of OAB? What is the length of AB? What is the length of this blue arc right here? What is this blue arc length? And well, we can figure that out. Well, first let's label the radius as 3 as usual. And well, we could figure this out using a very similar method as before, right here. And I'll actually give you a moment to think about it based on this formula, or if you have any questions about what we just talked about before, then feel free to ask. But give you maybe 3 minutes to 3 minutes to think about this. Okay, so does anyone have any ideas? Feel free to put it in the chat or unmute yourself if you want. As to what the length of AB is. Okay, so basically the way we figure this out is simply using this idea right here. So in case you didn't really understand how this idea comes from, where this idea comes from, we can also just think about it as, you see how this angle is determined by this circle right here? An angle is actually, a circle is just a representation of an angle. Since if we take an angle right here, a circle is a representation of an angle, since if we start with, say, a length 3 right here, then if we increase an angle, and if we create an angle with the same angle right here, with the same radius or same length on either side, then we will actually create sort of just the beginnings of a circle. If we go with every single possible angle from 0 all the way to 360 degrees, then we're actually going to create, slowly over time, we're going to build a circle like this. We're going to build a circle like this. If we increase the angle, it's going to build a circle. So what this means is that a circle is constructed out of an angle, and that the angle is going to be proportional to the length of your arc, or the piece of the circle you're going to create. But basically what this means is that we have this formula right here. And if we want to figure out the length of AB, we can simply solve that equation. We know what AOB is. AOB is equal to 60 degrees. And we know what C is. The circumference is equal to pi times the diameter, which is equal to pi times 2 times the radius, which is equal to 6 pi. As we remember, we solved this before. Since the radius is 3, 3 times 2 is 6, 6 times pi is just 6 pi. And then after that, we can plug this into the formula like this. So we have 60 degrees over 360 degrees equals arc length AB over 6 pi. And well, AB in this case is going to be, if we solve for AB in this equation, we can multiply both sides by 6 pi, right? So if we multiply both sides by 6 pi, 60 degrees, 360 degrees equals AB over 6 pi times 6 pi, then we will get, well, these two will cancel out, since if you divide by 6 pi, or, fractions, since fractions are just numerator over denominator divided by denominator, then we will get 6 pi times 60 degrees, which is equal to 360 pi. Or an easier way to think about this is to just divide 60 by 360 first. If we simplify that fraction, then we'll get 6 pi times 1 over 6 equals a arc length AB. Then if we multiply 6 pi by 1 over 6, we get pi, which means that the length of AB is actually literally just pi. Meaning that if someone, you could think about this as the Earth actually, or like a planet. If someone starts at point A and they walk to point B, well then they're going to have walked pi numbers of steps, if that was a sort of pi distance. If this was, say, 3 miles across, small asteroid. But basically that's how we can figure out the lengths of these arcs, of arcs like this, using the central angle. So what this is actually called is the central angle. And well, why is it called the central angle? Well, because it's the angle on the center. The central angle is in the center. And we can use this to figure out arc lengths quite easily. So based on this, we know that AB equals pi. Now, we could do a couple more exercises with this idea, but I think a cool thing to think about right now is the idea of radians. So radians are another way of measuring angles that we will probably discuss a bit more about next time. But basically, if we take a circle like this, instead of calling this angle 60 degrees, we can measure that angle simply based on the length. So let's erase this. So if we have a circle of radius 1, for example, then we can measure the angle in the center, this angle right here, AOB, in radians. And what is a radian? Well, basically what this means is that we can measure this angle based on the arc length itself. So for example, if this angle was 60 degrees, well then the arc length would be, remember that the radius is now 1, the arc length would be, well, over 2 pi, the arc length would be 60 degrees over 360 equals length of AB over the circumference, which would be 2 pi, right? Since the diameter is going to be 2, the circumference is going to be 2 pi. Therefore, we will know that it is going to be 2 pi times 1 over 6 AB, which will equal to 1 over 3 pi, or pi over 3, equals AB. And we can actually just say, based on this fact, pi over 3 equals arc length of AB, we can actually define this angle as pi over 3 radians. So what this means is that AOB is actually going to be pi over 3 radians. Pi AOB. This angle is going to be pi over 3 radians. And we represent radians with RAD, rad, because it is kind of rad. It's pretty cool. a lot more useful than degrees, because this will make solving for the arc length super easy. Because remember that radians only, like, you can only define radians as the arc length if the radius is 1. But if we increase the radius by a certain amount, well, then we simply just multiply it by the radius. So if, for example, if this was 2 instead of 1, and the radian measurement of the central angle was the same as pi over 3, still pi over 3, then we just multiply that by 2 to get AB equals pi over 3 times 2 radian times 2, which will just equal 2 pi over 3, meaning that in this case, the arc length of AB is just 2 pi over 3. So this idea might be a bit confusing right now, but we'll talk about this a bit more next time, but I just wanted to give you a little bit of a teaser about what's ahead. So moving on from this idea of arc length, we will now talk a little bit about area of a circle. So the area of a circle is basically just the amount of area that the circle takes up. So we have a circle right here. How much area does this take up? So how much space does the inside of this circle here take up? So let's fill it with, I don't know, gray. So what is the area of that gray space? How much space does it take up? Well, for example, if we take something like a square, like this, a square or a rectangle, let's just make this a rectangle. It's super easy to figure out the amount of area it takes up in terms of the squares that are here. So these squares right here. Well, we simply just count the number of squares that it takes up, right? You see that it takes up 5, 5, 5, 5. In total, there's 20. Or you could just multiply 5 by 4. 5 times 4 equals 20. Which is pretty simple, right, for a rectangle. But in a circle, you can't really do that, right? Since in a circle, there's just, it doesn't fit so simply into a bunch of squares, since that's what we measure area in. Well, instead, we can also use the idea of pi. So let's take a circle and let us split the circle down the middle, down the radius like this. Let's fill it. So let's split the circle down like this, right? So in this circle, we can actually kind of like unwind the circle like that. So if we start with a sort of rectangle, a circle in the middle, right here, if we start with like creating a sort of rectangular band like this, not rectangular, like a circular sort of loop like that, then what is the area of this loop? Well, so let's start out by saying that the radius is, say, 3. And then we can create a circle on the inside like this. Like that. And then we can create another circle, the outside right here like this. Like that. So what this means is that we can find the areas of these sort of rings around the center, like, which we'll highlight like this. So these rings, this ring right here, let's quickly see how we can figure out the area of this ring right here. So if we kind of unwind the ring into a rectangle, now it's not going to actually be a rectangle, right? Because this length in the middle is going to be shorter than this length out here. But if we approximate it as a rectangle, if we say that it's basically going to be, so it looks something like this. If we unwind it, it's going to look like some kind of weird trapezoid looking thing. Something like this. With these legs being 1 since we unwinded it. These two lengths will actually be touching together on here, but it's going to look something like this. And we know that the middle length is going to be equal to, well, the radius of this circle is going to be 2, which means that it's going to be 4 pi in the middle, and on the outer one it's going to be 6 pi. No, 6 pi. like that. Well, we can figure out the area of this. We can figure out the area of this trapezoid. But if instead we just look at the area here, which is just this, then if we just approximate it as a rectangle, then we can actually figure out and see that these legs are 1. We can figure out that this is actually going to be a length, a area of 6 pi, since 6 pi times 1, 6 pi equals, well, 6 pi 1 times 6 pi equals 6 pi. So if we can approximate this for every single part of the circle, sort of approximate the area of every single one of these loops. And in this circle in the center, well, we don't know what that is, since we don't know the area of a circle, but we could create an infinite number of smaller and smaller loops and find the areas of each one of them and add them up together. But an easier way to think about this is to instead just take your loops and then line them up right on the circle, right on the radius right here. So take your loops and just line them up on the circle right here. If we line up the second one, it's going to have a length of around 4. Bottom one is going to have a length of around 4 pi. Of 4 pi like this. Actually, it would be a bit easier to think about it like this. So let's take our original 6 pi trapezoid. So this is going to be 6 pi like this, right here, 6 pi. And on top is going to be 4 pi. And then if we take this ring right here, which is like this ring right here in the middle, we can actually create a new trapezoid that's going to look something like this. It's going to have a bottom radius, or the outer radius, which is going to be this length, the length of this circle. It's going to be 4 pi. And then the length of this inner circle is going to be just 2 pi. But notice how we can just stack this trapezoid right on top of the other trapezoid like this. And we will form a bigger trapezoid here. But what we need to do is now figure out what the area of this last little bit right here is. Right here. So let's actually highlight these to correspond. And then, but basically what we're going to do is we're going to create an infinite number of these smaller and smaller loops. So if we create even smaller loops, we will be able to stack these up higher and higher. And if we have infinitely small loops, like basically just like loops inside loops and inside loops, inside loops, inside loops, inside loops, inside loops, just an infinite number of loops, then we will be able to approximate the area of a circle. But eventually what we're going to end up with is a triangle that looks like this. A triangle that looks like this, because these are going to be smaller and smaller trapezoids inside. But if we start with really, really tiny trapezoids like this, what's going to happen is that the difference between the heights of each of these trapezoids, so this length, and that length, is going to get smaller and smaller as well, to the point where we could basically just act like they're rectangles. And if we literally build our triangle out of rectangles like this, eventually it will approximate a triangle. And the area of this triangle is going to be the area of the circle. Well, the base of the triangle is already going to be 6 pi, but the height of the triangle, is going to be actually just going to be the sum of all of these tiny lengths of these loops, which is going to be, well, the radius. So that means that in this case, the radius is 3, meaning that the area of this triangle is going to be 1/2 times 3 times 6 pi, which is going to be 3 times 3 pi, which is 9 pi. And if we just use the area here, well, this is going to be the circumference, and then the height is going to be the radius, which means that the area of the triangle is going to be 1/2 times the radius times the circumference, which equals, well, the circumference equals pi times the diameter, which is just equal to r times pi times 2 times the radius, which these two cancel out, meaning that we get pi r squared, which is the area of the circle. So this is kind of confusing because it is a very different concept from what a lot of you see at normal like math courses, because it involves infinite series. Like we're going to have to divide the circle into an infinite number of smaller and smaller pieces. But essentially what it means is that we can approximate each of these loops as rectangles and unfold them. And if we unfold the entire circle, then eventually what we're going to get is we're going to get a big triangle. And I think there's probably a much better like visualization animation of this available on the internet. But if you want to see that, I'll send a link later on. But essentially the area of a circle is always going to be pi r squared. And the radius is r. Radius is r. So what this means is that it's pi times the radius squared. So essentially what this means is that we have the area of the circle. So for example, if we have a circle with radius, say 2, like this, or whoops, like this, 2, then, well, the area is going to be pi times 2 squared, which equals pi times 2 times 2, which equals 4 pi. So this is how you can figure out the area of a circle, but it is a little bit complicated. But essentially, like later on, you'll learn a lot more about this idea of infinite division, probably in high school, because this is sort of the basis of calculus. But essentially, we can take the circle and turn it into a triangle. But the main thing is that the area of a circle, the formula for the area of a circle is pi r squared. And that is a very, very, very important formula for you to know just at all times, just to know. And I think that if you know this formula, then you should be good. So knowing this formula, A equals pi r squared, we can figure out the areas of all kinds of circles. So if we have a radius of, say, 3, a big circle like this, then we can figure out the area of this circle, 3. You can figure out the area of this circle like that using the area equals pi r squared formula. So does anyone want to give it a shot here using the formula pi r squared? What the area is. Okay, so basically it's not super complicated. We simply just use the formula. Since we know that the radius is 3, we use pi times 3 squared, which is 9. So we get 9 pi. And in case you don't remember, squared means r times r. So if you square something, you multiply it by itself like that, which means that r squared is just r times r. So it would be pi times 3, which is 9. 9 pi times 9, which means that the answer is 9 pi. So does anyone have any questions about how this works, or any ideas about what's going on here? Comments, concerns? All right. Well, if no one has any questions, then I think we should be done here. I'll send you guys a link to like a visualization of the area of a circle right now, actually. so that you can watch this afterwards. So but for now, we should be done. So thank you guys for showing up today, and yeah, all right, goodbye.